Welcome back to another episode of RX Tech Nonsense. Today I aim to answer a question absolutely no one has asked, and that question being, can Linux save 4-core gaming in 2025? It's no doubt that Windows these days is more bloated than me after I chow down at a Chinese buffet. With every fresh install, you're immediately bludgeoned with 1,000 different processes Windows would like to run in the background, including ads and data collection, all which they secretly disguise as tailored experiences that are supposed to benefit you. And this isn't even considering the Windows Defender constantly in the background, or Windows' infamously terrible update service. But now, is there a legitimate alternative to Windows for gaming? Will this operating system run like I used to back in high school, and reinvigorate the prowess of yesteryear's 4-core gaming? Or is even this not enough to save what was once considered the standard of the industry? And you may have already guessed, we will be putting Bazzite, an immutable distro of Linux, to the test. This operating system is extremely similar to SteamOS that is found on the Steam Deck, and reports are that users are seeing uplifts in performance comparatively to Windows. It feels like every tech YouTuber is covering this or similar versions of Linux at this time, but I want to know, just how significant is the boost that Bazzite has to offer, if any, and can it be used to resurrect old hardware, especially with Windows 10 rapidly coming to its end of life? The CPU I will be using for this test is the Ryzen 3 Pro 2200G, which I bought for the sole purpose to update a motherboard BIOS. This CPU released in 2018 and features 4 cores and 4 threads at 3.5 GHz on a 14nm process, with turbo up to 3.7 GHz. This CPU featured a paltry 4 MB of L3 cache and has a TDP of only 35 watts. This CPU is absolutely no powerhouse, but it makes the perfect test subject to see if the debloated environment of Linux offers any benefit over Windows. Of note, I will be using 16 GB of dual-channel 2400 MHz DDR4 RAM that I picked up off of Facebook Marketplace. This is not the world's fastest RAM, but I'm not entirely sure it's going to matter for this CPU. Given that the CPU is a Pro version, it really is limited as it doesn't even have overclocking abilities. Now this CPU does come with Radeon Vega 8 integrated graphics. In Rocket League at 720p and everything set to performance, we ended up seeing roughly 50 frames per second, with highs near 60 and dips into the 40s. So yes, it ran, but this was not an enjoyable experience by any means. Rocket League is also not an exceptionally difficult game to run, so this really doesn't give us a positive outlook for any other game we would be testing. Now, jumping into CS2, a slightly more CPU-demanding game, all graphics were set to low or performance mode, and resolution was set at 720p. We were seeing frame rate of somewhere in the 40s to 50s, with dips down into the 30s when action was high on screen. This was absolutely not a great experience, especially when playing a fast first-person shooter like CS2. However, take these results with a grain of salt, as I may have been unfairly testing this game, which I'll discuss a little bit later. Now, I didn't necessarily want to test these operating systems with the iGPU, since it will likely bottleneck the CPU and run at 100% utilization the whole time. More so, it will also eat into our system RAM availability. That's why I decided the only fair way to test this little Ryzen CPU was to add a dedicated graphics card. So that's where this guy comes in. I picked up this RTX 2070 Super off of Facebook Marketplace for a friend's build. This card will allow the CPU access to the full 16 GB of system memory and make the CPU the bottleneck in this test computer. So our performance will be reflective of what this maxed out Ryzen chip is capable of. Now it was just a matter of getting Windows installed and updates completed. I also went ahead and used DDU, or Display Driver Uninstaller, to remove any remnants of the Vega graphics drivers, since I was only able to get Windows to install using the iGPU for some reason. Then did a complete custom wipe and installed the latest NVIDIA drivers. If you want some foreshadowing, simply moving the Task Manager box was causing this CPU to spike to around 15% utilization. For my first test, I ran 3DMark's TimeSpy, just as a way to get a benchmark for the system. However, I'm a complete ding-dong though, since I thought I could get it to run on Linux as a way to compare, and I was very, very wrong about that. I couldn't get TimeSpy to run whatsoever, so unfortunately this benchmark won't really be able to compare between the two operating systems. As you can see, the system was pushing 50 up into 60 frames per second. That is more indicative of the stronger graphics card in the system though. Our real performance metric is going to be seen with the CPU test. Here's where the system immediately began to struggle. Looks fine here because I have the video on 4 times speed, so let's go back to normal speed. Oh yeah, 8 to 9 FPS is not good. With an overall score of 7,149, we hit legendary status, being the #1 system with these specs in TimeSpy, because no one in their right mind would ever run this setup. Both scores are from me. You can see the CPU score of 2858 is drastically holding us back. Now, jumping into our first game, Rocket League, we will be using mostly high quality settings. Of note, the graphical settings will be kept the same between both operating systems, and all games will be run at 1080p. Furthermore, I will be using Windows 10 for these tests, since this CPU does not support Windows 11, and this video is looking at potential alternatives once Windows 10 officially loses support. Here in Rocket League, I was seeing over 200 FPS the entire time, making for a fantastic playing experience. Of note, our CPU was hovering around the 50 to 60% utilization range, which allowed our GPU to stretch its legs a little bit. This system still crushes Rocket League, but I can't say this will hold true for more intensive games. Once again, getting into Counter-Strike 2, a more CPU-intensive game, I was running on the high default preset at 1080p as I knew the GPU would handle it easily. However, our CPU felt like it was beginning to develop arthritis in its knees. Our smooth frame times in Rocket League began to disappear here in CS2. Even though the CPU wasn't pinned at 100%, it was definitely struggling, forcing us below 60 FPS with constant frame tearing and crushing hitching and stutters. Overall, this was playable but not a great experience. Now, ramping the CPU intensity up a notch, we're jumping into Elden Ring at 1080p all high settings except motion blur, because motion blur might be the worst thing ever created. I feel like I don't see this game tested a lot though, probably because of its 60 FPS cap, but if you think we're hitting 60 FPS, you might be more delusional than I am. Right off the bat, we're getting frame rates in the high 30s to low 40s, which is still somewhat playable for this game. When using a horse, the frame rate drops into the mid 30s, which makes for a slightly worse experience. I did choose the Altus Plateau region as it is supposed to be one of the more CPU demanding regions of the game. However, I can say from my experience, this is about the same frame rate you'll get consistently throughout the game. There were definitely stutters and lags, but it was hard to tell if it was the CPU being overwhelmed or if it was just the game, because even on higher end hardware, this game will randomly stutter. For example, this instance here, the CPU utilization actually drops to about 50%, meaning the stutter wasn't caused by overload to the CPU. Putting Elden Ring aside, I am going to move into an even more demanding game, Cyberpunk 2077. This game has been known for the past few years as a true test for hardware limitations, and even in the menus I was seeing almost 100% CPU utilization. For this game, it will be run at 1080p with DLSS turned on, ray tracing set to off, and all other settings at a mix of high or ultra, except for motion blur, which of course I turned off. Importantly though, I set crowd density to low to take as much stress off of the CPU as possible, to give this processor the best chance at a positive performance. However, my hope was short-lived as this game was playing at, let's say, a cinematic frame rate near the mid-20s. There were even some excursions into the 30s and close to the 40s, but these are short-lived and the performance is not stable. Now, moving out of the more densely populated cities does cause the frame rate to jump up closer to the 40s or into the 40s more consistently, but the game doesn't solely occur on the outskirts of the city, so this is not a great playing experience, but it does beg the question if Linux would make this any more playable. Our final game is going to be quite a bit of a stretch of what we can get away with, as it literally warns we need at least 6 cores to run smoothly, and well, our 4 cores definitely don't meet the requirement. But testing an Unreal Engine 5 game like Oblivion Remastered will show us exactly how much juice this CPU has left in the tank, or if 4-core gaming isn't even going to be possible going forward. For this game, our settings are at 1080p with ray tracing turned off, DLSS set to balanced, and mostly all other settings at medium. Now, when we got into the game, this was an odd one. The FPS counter on screen showed the game running pretty consistently in the mid-30s up to the 40s, with the occasional dip into the high 20s. So overall, this game felt more playable than Cyberpunk, but my screen capture card really made it look like a slideshow for some reason. You'll have to take my word on this one. Now, I'm not saying it was a fantastic gaming experience by any means, but in person it felt way better than what it was being shown on screen as. Now that we have our benchmarks for what performance we can expect on Windows, it was time to switch over to Bazzite. This is not an install guide, but if that's something you'd like to see, drop a comment and I could probably make that video happen. After I successfully downloaded Bazzite, it was time to install our Steam games. Of note, all the games I will be testing, I will be running with the compatibility layer Proton Experimental, except Counter-Strike 2, which runs natively on Linux. But now, for the moment of truth, as we portal through the quantum realm and achieve hyperspeed gaming with Linux. Wait a minute, does that say 70 FPS? This can't possibly be right. Well, I sort of have an explanation for our decreased performance in Rocket League. So, if you remember correctly, this was the one game that was not completely CPU bound on Windows. With that being said, gaming in Linux tends to favor AMD graphics cards and can hinder NVIDIA performance. Generally, it's reported as a 12% drop or about a 12% drop from Windows for NVIDIA cards, and mind you, we are using an RTX 2070 Super, which is an NVIDIA card. But on Windows, we were gaming at around 200 FPS. So that definitely doesn't explain this massive drop in performance. Now, as far as I can tell, this is due to a loading of the Vulkan shaders. Once complete, a significant jump in performance can be seen for this game, and the FPS increases to between 120 and 140 consistently. That is a perfectly playable experience, but is still about 70 FPS drop from our experience on Windows. Now, considering all of that, we'll just have to see how the other games perform. Up next was Counter-Strike 2, where I immediately ran into an issue with preloading Vulkan shaders. Preloading would take multiple minutes for each percent, and I had averaged that it would take me about 3 hours to completely preload the shaders for this game. Mind you, I had similar issues with other games, but was able to fix the issue by clearing my download cache. CS2 being the only native Linux game seemed to make this issue unfixable. From my research and some helpful minds on Reddit, it seems that Linux only dedicates one CPU core towards the preloading of shaders, so there is a way to manually dedicate more cores to the process to speed it up, which isn't a problem for most people with a modern CPU. But logistically, this was an issue for me as I only had 4 cores and would have liked to at least reserve 2 for the operating system itself. Really, the answer became just skip it and then let them load in the game itself, which may only cause some stutters for a few minutes. So here's some gameplay from a few minutes into my play session. You can see the game is sitting somewhere in the 50 to 60 FPS range, but dropping into the 40s at times. Honestly, this just felt a little bit worse than my experience on Windows. I would like to blame it on Linux, but I think the majority of the issues are coming from the CPU itself just being underpowered. Jumping back into Elden Ring, we can see that our FPS was sitting right around the mid-30s, which is only slightly less FPS than what we were seeing on Windows, which was generally in the higher 30s. However, there wasn't any stuttering or hitching on the Linux version while I was playing, so I'm actually going to give Linux a win for this. Sacrificing only about 2 FPS to remove the annoying frame drops is absolutely worth it. Now, in a dire situation, you could probably get away with this game being playable. Now, Cyberpunk, on the other hand, felt like the first game I managed to see a slight performance increase. On Windows, we were sitting in the mid-20s in the city, but on Linux, it was closer to 30, and definitely felt a little bit smoother. Once again, the FPS would increase into the 40s on the outskirts of town, but overall, this did not make the game feel like it would be a great gaming experience, and I think anyone in their right mind would opt to get better hardware to run this game. Now, last but not least, our favorite Unreal Engine 5 game. Warning once again that 4 cores will cause mental agony, and they cannot be held liable for your sanity if you decide to play anyways. I'm going to be blunt with the performance of this game. It looked and felt significantly worse, with FPS in the low to mid-20s, with drops down into the teens. This is absolutely a loss for Linux. The game felt potentially playable on Windows, but this experience would be enough to want to tear your hair out. So what are my big takeaways from this video? Number one is that Linux is cool and it's really awesome there's an operating system aside from Windows that can be used for gaming. I'll likely find myself experimenting with different distros in the future, since this was just me getting my feet wet with Linux. Number two is that Linux/Bazzite is not a silver bullet for old and obsolete hardware. Gaming performance was still about the same or slightly worse in the majority of the games we tested. Now, maybe if you just want to do day-to-day tasks and have an old system incapable of running Windows 11, this may be a good option. And number three, as a man of science, just because my experiment didn't show massive performance gains doesn't make it worthless. Just because I've heard many YouTubers say that they've gotten performance boosts doesn't necessarily make it true. Sometimes the most valuable information and studies are the ones that show no difference. Now, I would like to go back and compare the performance with better hardware, so maybe in the future I'll do that. Now, if you've made it to the end of the video, I want to give a huge shout out to you. I really appreciate it. These videos are passion projects, and I hope you find them as fun as I did. If you liked this video, feel free to subscribe and come back for more. If you're new here, check out my previous video where I built a computer using only sketchy components. And hey, I'll see you all in the next one.